Hello everyone. So in this video, I'm going to go over some of the problems in the midterm study guide, and I'm going to start with numbers 19 to 21, and then I'm going to move to the z-score and the z-table problems. So let's look at number 19. If we if we have the following data set, 1, 3, 6, 9, 15, which measures of center would be impacted by changing the value of 15 to 35? All right. So this data set is already arranged, 1, 3, 6, 9, 15. Now, because it's already arranged, if you decide to find the median, it's going to be the middle number, which is 6. Now, if I change 15 to 35, the median is still going to be 6. It doesn't change, even though the greatest or the largest number changed. For the mode, if I change uh, 15 to 35, the mode does not change. There is no mode. If you keep 15, again, there is no mode. So it doesn't make any difference. But for the mean, it's going to make a difference. Why? Because for the mean, we are adding all the values. So if one of the numbers changes, like in this problem, 15 changes to 35, it increased. So that tells us that the mean is going to change. The mean is also going to increase. So the mean is going to be impacted by the change, but the mode and the median are going to be the same. Now let's go to number 20. Now in 20, it says, given the two sets of data, which will have the larger standard deviation? So here for set one, we've got 1, 1, 3, 3, 5, 5. Now, because we know that for standard deviation, you're looking at the deviation from the mean, or the average deviation from the mean. Now, you could also tell if a standard deviation, I mean, if two sets of data with two different standard deviations, you should be able to tell which one is larger by looking at the data sets. Now, if you look at set one, you've got 1, 1. Now, let's look at the differences or how spread out this data is. 1, 1. Now, from 1 to 1, this is for set 1. So that's where I'm starting from set 1. From set 1. So, so for set 1, you've got 1 and 1, 3, 3, 5, 5. Now, going from 1 to 1, if you look at the difference, is 0. From 1 to 3, it's 2. 3 to 3 is 0. 3 to 5 is 2. 5 to 5 is 0. So you're looking at 0 and then 2. Now, when you go to this set, you have set 2, you have 3 to 5, which is 2. 5 to 9, which is 4. 9 to 16, which is 7. 16 to 20 is 4. So right there, you know that for set 2, it's more spread out. So that would have a larger standard deviation. Okay, and that's it. Or you try to calculate for this. Calculate the standard deviation for both. Now, when you go to 21, we're trying to find the set with the smaller standard deviation. Set 1 has 15 to 16, which is 1. If you look at the difference, we are trying to look at how spread out it is. 15 to 16, 16 to 17 is 1. 17 to 19 is 2. 19 to 21 is 2. Okay, now let's go to set 2. Now in set 2, you have 1 to 5, which is 4, 5 to 13, which is 8, 13 to 16, which is 3, 16 to 25, which is 9. Wow. So with set 2, the data values are more spread out. So set 2 has a larger standard deviation. So we're going to choose set 1, that has a smaller standard deviation. So that is how to know in comparing standard deviation of two different data sets. All right. All right. Now let's look at problem 28. Find the area under the z-curve to the left of z equals negative 1.56. So the first thing I would do, as I already told you in class, is to draw. So I'm going to draw. Okay, this doesn't look good. So it's difficult trying to use the cursor to draw. All right. So you know that the middle part is 0. That is the mean. Now, negative 1.56, that is going to be on the left because it's negative. And it says the area to the left. So that area. Now, the next thing you do is to go to your table. The table is always going to give you the area to the left. So you go to your table and then find that area. So I'm going to share my table. All right, so this is my Z table or my standard normal table. And I'm looking for negative 1.56. So right here, I see negative 1.5. Where are you? Okay. So that is negative 1.5. Right there. And then the 6, the 0.06 is going to be here. So this brings me to that. So that gives me a 0.0594. So my area to the left is going to be that. And that's it. Okay, that's it. That's all you do. Let's go to the next one. Find the area under the curve to the left of 2.01. 2.01. So 2.01 is positive, so it's going to be somewhere here. And then it says area to the left. Okay, to the left, not to the right. So to the left. Okay, let me redraw this again. All right, so area to the left. So that is going to be a bigger area to the left. So you go back to your table. So let's do that now. And look at the positive, or find the positive Z table. Yep, I got it. So 2.01, I've got 2.0 here, and I'm looking for 0.1, and 0.1 is also there. So, yep. And that brings me to 0.97, 0.9778. 0.9778. And that's it for that one. So let's go to the area to the right, because that is when it gets more complicated. Find the area under the curve to the right of z equals 1.83. So just like I keep telling you, try to draw, because that is going to help you a lot if you draw. So let's try to draw. So if you draw, this should give you, okay, let me draw. And then you have, okay, please forgive me. Because I'm using the cursor, it's just difficult. You know, this doesn't look like a curve, probably looks like a snake, but just forgive me. Uh, yeah. So, area to the right of 1.83. So this is the mean, the middle value 0. So 1.83, I'm going to put that here. Oops. 1.83. Let's put that somewhere here. All right. So somewhere here, 1.83. 1.83, and it's to the right. Now, I did show you two ways you can use, or two methods you can use to find the area to the right. Okay. And I love using this one. I prefer this one because that helps me understand how the area under the curve works. So I'm going to go to the table, find the area to the left. Remember, the table would always give you the area to the left. So the area to the left of 1.83. And then after that, I subtract to get my area to the right. So if I go to the table, 1.83 is going to be, yes, 9.9664. 0.9664. Let me draw it again here. So 1.83, and then this is 0. This is area to the left. And then here you have 1 minus 0.9664. And you put this in a calculator, you're getting what? 0.06, I mean 0.0336. And that's it. That's it. All right. The next one is, oh yeah, I think I skipped one. Number 30, find the area to the right of z equals negative 0.84, negative 0.84. So again, same thing, to the right. So you draw, and then this is 0, it's negative, so negative 0.84. It's to the right. So I'll go to the table, find the area to the left, and subtract from 1. So let's do that. Okay. So it's negative, so I'll go to the negative table. Negative 0.8, or is it? 4. Oops. So this is it right there. And then that is point, and that is 0.8. Oh, what happened to my screen? Okay. I think something happened to my screen. So let me try this again. Yep, that is 0.8, that is 0.4. So it's going to meet out here. And that is 0.2005. So if I'm going to redraw this, or draw this again, then I'm going to have that, oops, and then that, and then 0.84 negative, of course. I'm going to put a negative there. Negative 0.84. Now I just found the area to the left of it. Yes, I'm trying to shade it. And this is 0.2005. Oops, 0.2005. And that is not what I need because this is area to the left. The problem says find the area to the right. So what do? I subtract this area from 1 so that I get the area to the right. So this is what I need. So 1 minus 0.2005. And that's it. Okay. That should give you 0.7995. All right. The next one is to find the area between. We did an example like this in class, but we're going to do this again. So first of all, I'm going to draw. So this is 0, negative 1.56, negative 0.84. And then because both are negative, yeah, you've got to put it on the negative side. So this is the area I'm trying to find. But the thing is that I could to find this area, first of all, I'm going to think of it this way. Find the area to the left of that. That's negative 0.84. So if I find that area, it's like everything to the left, like that. Everything to the left. So I'll find that first. And I think I already found that, maybe not. But yeah, I think I found that when I was trying to find the area to the right of z equals negative 0.84. And that area, if you remember, that was 0.2005. So that is everything to the left. So that's the bigger area to the left. And that's to the left of negative 0.84. And then I'm going to find the small area, and that is from negative 1.56, this area. Why do I have to find that? Because if I find that small portion, then I subtract from the bigger area 0.2005 to get this middle part, Yep, to get that. And the area to the left of negative 1.56, if you go to the table, we already found it in question, I think 29 or something like that. That was 0.0594. So that is this small area, 0.0594. And then you do your subtraction. So we're going to have 0.2005 minus 0.0594. And that's it. That should give you your answer. Okay. All right. Now I'm going to go to number 36 and then go over those problems as well. So in 36, this is what we have. Mandy is headed to her doctor's appointment and does not want to be late. The drive time from her house to the doctor's office follows a normal distribution with an average of 28 minutes and a standard deviation of 7 minutes. It decides to leave 40 minutes early. What is the probability she is late for this appointment? And it takes longer than 40 minutes to arrive. So in this problem, it's telling us that Mandy, she wants to leave 40 minutes early. So we want to know the probability that she is late for this appointment. Remember, it says it takes longer than 40 minutes to arrive. Okay. So, first of all, you have to draw. This follows a normal distribution, which is good. So we know that we can get our curve. And then, now, we have a normal distribution, but we can change the normal distribution to a z, or standard normal distribution. Remember that formula? Z equals x minus the population mean divided by the population standard deviation. And in this case, our mean is 28, our standard deviation is 7, and then our x is going to be the 40. Now, even before we change it. We change to a z distribution. We know that we are trying to find the probability that x will be greater than 40. Oops. Will be greater than 40. That's what we're trying to find. Because she's going to be late if the time she took to arrive there was more than 40 minutes. So that's what we want to find. So to change our x to a z, we have x minus mu divided by the standard deviation, which is 40. So x is 40 minus, so 40 minus 28, which is our mean, divided by 7, which is our standard deviation. If you put this in a calculator, it's giving us 12 divided by 7. 12 divided by 7. And then you want to put that in a calculator and you're getting 1.71. Remember, z distribution or z score, you round to 2 decimal places, 1.71. 1.71. So we've changed our x to a z score. So now our probability is going to change this way. The probability is going to be, oops, where is it? Yep, the probability is going to be P z is greater than 1.71. 1.71. 1.71. If I want to put this on there, I have 1.71 here. Because we are looking at greater than 40, that's going to be to the right. Remember, it increases to the right, like a number line. So greater than 40. So the probability that she's going to be late is going to be the area to the right of 1.71. Area to the right of 1.71. Okay? All right. So let's go to our table and then find that. So this is 1.71 is positive. So I'm going to go to the positive side. 1.71, where are you? Where are you? So 1.7 is right here. And then 1 is 0.9564. 0.9564. Remember, this is to the left. But we need the area to the right. So 1.71. So this is 0.9564. So you've got to subtract 1 minus 0.9564, and that should give you your answer. That should give you your answer. 1 minus 9564. And that should give you, if you put that in a calculator, let's say 6, 3, 4, 0. So 0.0436. 0.0436. 0.0436. That is going to be your probability that she was late for her appointment. All right. Now let's quickly go to number 37 as well. Number 37. Now for 37, I'm not going to go through everything. I'm hoping that I'll show you how to get it, and then you finish solving it, so that I would go to 39 and then probably the last one, 40. Okay. So in 37, you've got a new questionnaire is developed to determine the happiness of people. The average score for people follows a normal distribution with a mean of 50, a standard deviation of 15. Okay. Based on the grading scale, a person is deemed truly happy if they score 70 and above, and truly unhappy if they score 25 and below. Answer the following questions. Based on these claims of the new questionnaire, what proportion of the population is truly happy? Score greater than or equal to 70. So right there, it gives you a clue. Score is greater or equal to 70, which means 70 or higher. So that is the area to the right of 70. But we want to change 70 to a standard normal distribution first. So we're going to go to our formula again, and then that is z equals x minus our mean divided by standard deviation, which is 70 minus my mean is 50. And standard deviation is 15. So that is what I have. And then you put this in a calculator. So you have 70 minus 50 is 20. And then you divide that by 15, which gives you 1.33. Remember, 2 decimal places for z, 1.33. 1.33. That is our z. So if you draw your area or your curve before we go to the table, probably let's go to the table. There I have more space. So you're going to have 1 point, if there's a 0, 1.33 should be somewhere here. So greater or equal, so greater, that's there. So it is to the right. So you find the area to the right. So find the area to the left from the table and then subtract from 1. So that is going to be, what is it? 1.3 right there. And then here you have your 3. So you're looking at that 0.9082. So that is this guy here. And then you subtract from 1. So if you subtract from 1, you're going to have, let's say, 1 minus 0.9082. And that will give you 0.0918. 0.0918. And yep, and that's it. That's what you have. Now for the next one, it's telling us to find people who are truly unhappy. So to do that, again, you're going to draw. Probably let's go back to the question. Let's go back to the problem and then check what is going on. So with this one, it says, those who are truly unhappy, oh, it says it right here, score 25 or below. So that is area to the left. 25 or below, area to the left. But first of all, you've got to change 25 to a z-score. 25 to a z-score. So 25 minus the mean, which is 50, divided by 15. 25 minus 50 divided by 15. So 25 minus 50 on top will give you a negative 25 divided by 15. So here you are getting a negative, and that should give us negative 1.67. Negative 1.67. Remember, you've got to round. Negative 1.67. And then you go to your table. You go to your table. Then you find the area to the left of 1.67. So this would be something like that. And then you have negative 1.67. So I'm going to say negative 1.67. It says 25 or fewer, so to the left. So here you only do to the left, and that's it. 1.67, 67. Yep, and then right there. Right there. You have point. What is it? Oh, yeah, this is positive. So go to the negative. Yep, this is positive. Go to the negative. 1.67. Where are you? 1.67. Yep. Negative 1.67. So you have 0.07, 0.0475. Oh, I think I'm tired. 0.0475, and that's it. All right. Yep, I'm tired, but let's finish it. Let's finish it. Let's go to problem 39. Now in 39, we are looking at the central limit theorem. We are looking at the central limit theorem. Now with the central limit theorems, like you're finding the mean of the mean. So you have a local soda shop fills their soda bottles with a process that follows a normal distribution with a population mean of 32 fluid ounces and a population standard deviation of 1.1 fluid ounces. If we sample 36 soda bottles, what is the z-score pertaining to a sample mean of 32.6 fluid ounce? Now, here you have the first thing you would see is that you have two means. The population mean of 32 and a sample mean of 36.6. So right there, you know that, oh, I'm working with the central limit theorem. Now, the formula to work with the central limit theorem, it's going to be here. Where are you? Where are you? Yep. It says Z statistic sample mean, Z sample mean, this formula. You have the standard error at the bottom, X bar minus mu on top. Remember, the question says find the z-score. So here you are finding only the z-score. You don't find probability, right? If you are supposed to find probability, it's going to tell you, and then since you have the z-score, you use the z to find your area or the probability. Here you only find the z-score. So we are going to use the same formula that I just showed you. The z-score is going to be z equals x bar, which is the sample mean, minus my mu over, okay, this is not working for me. Let me change to trying to use my phone to get this all situated properly. But you know what I'm doing. X bar minus the mean or the population mean divided by the standard deviation over the square root of n. Oops. Yep. Yep. Divided by the square root of n. So now you have to find your values and then put them in. So you should know what the sample mean is. You should. All right, sorry about that. So Z again is going to be x bar, now it's writing better, minus mu over the standard deviation divided by square root of n. So z equals x bar is 32.6 minus, which is the sample mean, minus 32, which is the population mean, 32 divided by the standard deviation is 1.1 over the square root of n, which is 36. And then now it's all about knowing how to put this in a calculator. Please make sure you know what the square root is, because some of you do not know where to find the square root. The square root is not the same as a square. All right. Know this. If you don't know where to get it, I don't know how to show it to you now. I did show some of you in class. Just go on Google and then just do, how can I find a square root on a calc? Just make sure you know what the square root is. So with the calculators you have on the exam, you have to do the bottom first. So do the bottom first, write it down. So square root of 36 is 6. So you have 1.1 divided by 6. Put that in a calculator, write it down. And then do the top part, 32.6 minus 32. And then now you divide the two answers to get your z value. Yes, and that's it. It says find the z-score. That's it. Now, with number 40, same thing. You have a mean of 16, the mean, and then the standard deviation of 1.4. These are the population mean, or mu, and then population standard deviation. If we sample 64 packages, which is n, and find the mean of those packages, which packages, the sample. So the mean here is the sample mean x bar. What is the z-score corresponding to this value? So you use the same formula and then put the values in and then put it in a calculator. All right. So this is where this video is going to end. You could see that I'm tired. But thank you for watching and keep smiling. I wish you the best on the exam. Bye.